All right, I've made, okay. So we have started the recording for today's session. And today we are primarily going to talk about the computing engine behind Hadoop. Okay. Why the architecture and what's the need of it and how does it work exactly. Okay. So you will have a lot of questions. Do not hold the questions. Ask immediately so that no question goes unanswered. Let me turn off all my instant messengers. Okay, mute. All right. Let me also turn off my phone. All right. Yesterday's recording has been updated, Ashmeet. Isn't it reflecting in my courses, 6 Feb? And if you go into session number 3, it should be reflecting over there. This one, it's not updated yet. Ouch, looks like. Okay, you are right. I don't know where did it go. Let me just check. All right, let me just check. I had updated here. Okay, let me check. Okay, all right. Extremely sorry for this not getting updated. Okay, all right, great. So if you have any questions regarding yesterday's session, okay, then you can let me know. All right. All right. So there is a question from Ashok. Can you explain once the copy from local and copy to local command with an example? Create a file with a nano. Okay. All right. Good. Let me try. All right. So we are going to first log in into one of the web consoles. We are logging into the console. Basically, we are logging into the command prompt of H5. Okay, it's once you log in, it will behave as if you are standing inside that computer, and executing these commands. Okay, so here you're standing inside the computer there on H5, and remotely we are executing command. Okay, so anything I do here, I'm doing it from our server H5, okay, which is in US. Now let me try to explain to the example with a case. First, let's create a file. Okay. All right. There is a good question from Enian. I'll talk about it. Okay. So let's first create a file in the local directory. This is our present working directory where I'm working. This is my local folder, as in it's not inside Hadoop. Okay. So here, let's say I'm creating a file using Nano. Nano is an editor, text editor, just like you have Notepad. Okay, just like you have Notepad in Windows, here we have Nano. We can start Nano with my some new file txt. Okay, here you can write. Here is some text. I'm writing some text. Then I'm pressing Control X to exit, and then I'm saying save modified. That's it. It has saved my new .txt. Okay, it has say created this file. It's as if you have opened a notepad and saved some text in it using notepad. You can see that cat my new shows that there is some text here. Now let's upload this file onto Hadoop. And how do you do that? We say Hadoop fs minus copy from local, all right, and say mynew.txt. Now this mynew.txt will go into my home folder in HDFS. All right, looks like it is done. Let's open Hue. Let's open Hue, and under the file browser again, if you don't have access to the file browser, you can click on it and see that. Okay, now when I click on home folder, this is what I get. Yes, I have started recording. All right, so we have just uploaded some file. It would be somewhere. Let me just sort it by date. Okay, now I've sorted by date, so I can see that it is here. See that? Now from here also we can edit the file. Okay, this is some other text. All right, good. You see that these two lines are here. Good. So we have created a file. The first thing we did was we created a file using Nano, and then we copied the file. So what we did, I'll just write the script here. We said Nano, then we exited from Nano and saved it, and then printed the data, and then I uploaded it, and then opened file browser. Okay, and then edited the file. Okay, after locating it in the browser, and afterwards I I'm going to bring it back to the local. Right now my new.txt locally still contain the old text. Why? Because it's local. So now I can delete my new.txt, and then I could say copy to local. Okay, copy to local. All right, so now you can see that the new text which we put in using hue is also available in this file. Good. Does that answer your question, Ashok? Great. All right, a question from Anian. Is everybody having a clear voice? Because Anand is having a little bit audio issue. Okay, is my audio coming through clear? All right, looks like for everybody else it's coming clear. Anand? Yes, Anand. Yes, Sneha, everybody is muted. All right, great. Now let me answer another question. The question is how to change the permission in Hadoop. Okay, let us say we want to make this file public and everybody should be able to edit it. Okay, so first let's have a look at what is the current permission of this file. You can see nobody else can write it other than Sandeep Giri 9034. All right. If I want to make if I want to make everybody else change this file, or if I want to make it complete secret, let me first make it complete secret. I'm saying 700. Now, what does it mean by 700? Okay, it means nobody will be able to read it. Only I, which is the user, will be able to read and write it. Okay, the owner has read write both permissions. Okay, I hope that answers your question. All right. Next question from Satyan Leela is in Hue, how to see local file? File browser only shows files from HDFS. Is that correct? Yes. File browser only shows files from HDFS. It doesn't show local. The only way to see the local file is either using WinSCP. There is a software called WinSCP. Okay, you can use that one, or ls kind of commands like commands like ls find, etc. So Ashok's question is, when we are copying back to edited the file and then we said copy to local, here we also deleted the file and then we said copy to local. Yeah, we did copy to local because otherwise it will say that the file already exists. All right. A question from Muhammad Abu is that can you please talk about users in Hadoop and home place in Hadoop HDFS? Okay. So users in Hadoop basically are generally similar to the users in the normal local file system. They can be different. They can be different. If they are different, then you will have to use sudo command or hdfs minus u command, okay, in order to access the file as some other user. All right. So all the users which are in Hadoop should also exist in the local file system. That's the general way of handling Hadoop. A question from Prabhu. I have copied HiveJar's folder to my local using copy to local. I can see it in my Hue, but not where it got saved in local. Actually, any folder with the name starting name dot is hidden. Okay, any folder is hidden, so you will have to use ls minus la. Okay, so for example, here you can see there are so many files, but when I say ls minus a, that time you will see extra files like bash history, bash logout, hive history, and so on. Okay, Ashok's question is Hadoop fs minus ls and hdfs dfs minus ls both are same? Yes. Both actually call the same thing, same class. Alright. Mohsin's question is how can I move a file into a directory that are on Hadoop file system from command line and Hue? Okay, so you can use web console, web console for moving from, say, from a computer in cluster, say H5, into Hadoop and back. Alright. Otherwise, you will have to use Hue to copy slash moving. Okay. To copy slash move from your from desktop to Hadoop and back. So you can use Hue to upload files from your desktop into the cluster or download the file from Hadoop to your desktop. Mohsin, does it answer your question? All right. Prabhu's question is if you created a user on one data node, can the user access any data node? Okay. All the data nodes in your cluster should have same user ID. Okay. So whosoever is running the command Hadoop will be the user. The Hadoop command would expect the same user to exist in HDFS. All right. I hope that answers your question. Very brilliant set of questions, and I'm sure these are useful for all of us. Okay, so question from Mohsin is what if I have a file and a directory both in HDFS? How would I move it? In that case, you should explore a little bit about this command. Where is that console we had? Yeah, here. If you see Hadoop fs minus fs, there is a move command which is you can see here. So let's say I have a directory called temp in my home folder in HDFS. Okay, I want to move the file which I recently created into temp. So I say Hadoop fs move. So now the my new.txt has been moved to temp folder. You can see that inside temp you see my new.txt. Okay, good. All right. Prabhu's question, follow-up question is, so admin has to create account in all the nodes? Yes, on all the nodes where a user is trying to log in from. Yeah. Question from Anand is, do we have a copy of all the questions saved somewhere? So this notes, whatever we are having in the discussion, is will get uploaded here, like discussion notes here, and discussion notes here. All right. This one is not yet updated. Let me check. I think session number 2 we did not have much of notes. All right. Anian's question is, how to upload a file from desktop to Hadoop. Use Hue. Okay, you can use Hue, and in Hue you could upload using upload option. You can click on upload and yeah. All right. Okay. So I hope everybody's question is answered now. All right. So if you want to actually see whether it is happening or not, you could click on upload, select files, and then let's say, okay. All right. The file has been uploaded. You can see that I uploaded it from my desktop, the laptop which I'm working on right now. It has been uploaded here. All right. A question from Rajiv is, do we have Hadoop installed option on Windows 2? Yes. You can basically download the VM and try it out. All right. You could go to here, and there one you should generally review Cloud Lab Explained, and before that you should actually go through the installation instructions. Okay, these ones talk about the virtual machine. Okay, they talk about virtual machine here if you want to install Hadoop on your desktop. All right. All right, a question from Ashwini. I'm not clear about copying moving file from web console and Hue. Can you please explain again, specifically that you mentioned desktop and computer in cluster? Okay, so we have 5 computers right now. Okay, I would actually recommend you to go through this particular notes. Okay, this one I have tried to explain here. Okay, with a diagram. Okay, you can see that this is your desktop. This is Hadoop 1, H1, H2, H3. Okay, and there is Hadoop HDFS. So HDFS is common for all, while every machine is having their local file system, whether it's my Mac or it's your Windows desktop, or so they will all have their own file system also. So you might have to copy the data from your desktop to H1 or H2. You could use PuTTY or WinSCP. So instead of using H1, H2, you should try H4 and H5. Okay, so you could use PuTTY and WinSCP to interact with these. And Hadoop, any of these machines, if they want to talk directly to the HDFS, you can use a command like Hadoop fs-ls, okay, and Hadoop fs-copy to local. Similarly, in case you want to directly talk to, okay, so if you want to directly talk from your desktop to HDFS, you should use Hue. Okay, so Leela, you can't see local files in Hue. All right. A question from Sukhvinder's question is: do we need static IP addresses when we create cluster? Not really. The domain name is sufficient only. Okay, if you have created a domain name, that is good enough. All right. Ashwini, does it make it clear to you? All right. So Sneha's question is: I'm not clear about creating clusters. Okay. All right. So one is there are two ways of creating cluster and working. One is first and primitive one is that whatever we have, you start using that CloudX Lab. So you just log in into console and start it. But if you want to create your own cluster, you have two options. One, you use the installation instructions here on how to download virtual machine on your desktop and run the virtual machine on your desktop. Other is you use Ambari. Okay, here is the step-by-step steps to install Hadoop on a cluster using Ambari. Okay, just go through that and here, if you go through this, it'll give you a very clear idea. All right, so go through the LMS and most likely you will get a clarity. All right, so you can download a VMware. If you have already VMware, you can download VMware virtual machine from Hortonworks. All right, Sneha, does that answer your question? Great. All right. Okay, so most of the documents are here. You can see session number one. First one is the quiz you can take, and then installation instruction. First half of this installation instruction is how to access CloudX Lab. Okay, second half is dedicated to Ambari, and then and here in the first itself, you will see the regular expression. You all must go through the regular expression session as well. Okay. Then in the second session, you have the clarity on CloudX Lab. How does it work? And I think the same link has been pasted twice here. Okay. And so on. All right. Is that you're looking for? All right, Sneha. Okay. A question from Prabhu is Hue just has to be installed on one data node to be used by all users. It is up to us. Up to us. Okay. Generally, you should keep a single hue. Okay. But if you have too much load on one hue, you can install multiple hue. Okay. All right. As you told, we use Hue to watch the thing happening on HDFS. So in real life projects, company use Hue or we focus on command more. Generally, in the real life, we focus on command more. Okay, reason being that with command, you can automate a lot. And most of these processes being batch oriented and server side, we try to automate as much as we can. Generally, in the companies, people focus on command line more. Great. Now, moving ahead. All right. Great set of questions. Great set of questions. All right. So, earlier we talked about why do we need big data, aka, also known as distributed computing. And then we talked about a distributed file system called HDFS, where the files are sliced into small pieces and distributed on multiple computers. Then we talked about we talked about a problem of processing. Okay, so why when we talk about processing, why we talk about sorting in general? Processing could be anything. Okay, processing could involve as simple as multiplying 3 by 4. Okay, or processing could be as complex as doing certain very complex mathematical operation like compression is a very complex mathematical operation. When you zip a file or uncompress a file, it's a complex operation. Okay, so why do we talk about sorting as the benchmark for computing? So there's a common scenario in the industry, in the computing industry. Whenever we talk about processing, meaning we are doing heavy processing, what we generally take an analogy of processing with sorting. Okay, why do we do that? Okay, let me test quickly. Let me see if you are on the same page as me. Okay, so first reason of that is, all right, so question here is, why do we take sorting as the main um, processing thing? All right, let me ask you a few things. Which of the following commands, okay, are impacted or impacted by sorting? Impacted or involve. So, which of the following commands are impacted by or involve sorting? Number one, number one. Let's say select star from a table where name equals. All right. Okay. So select star from a table where name equals Sandeep and name has index on it. Okay, question to you. Does this querying involve sorting in any way, or is impacted or related to sorting? Is creating an index on a table get impacted by sorting? That is my question. Yes or no? All right. Let me rephrase the question. So, does creating index involve sorting? Yes. Great. So, when we say select star from this, a name has an index on it. Suddenly, if a column has index on it, meaning we prepared a kind of index on the backside of the book, suddenly the lookup becomes really fast. All right. So, okay, a quick question to all of you. Let me see if that's a interesting question. So, how many of you have you used a library with no computerized book lookup? Anybody has used? Vishnu, have you used? So, did you have a physical index where you will go and try to search for the book? All right, Sukhvinder had. Interesting. All right. So, okay. So that's like really arcane, and we at our college in first year had non-computerized book lookup, and our library was around as big as most of the how should I say? It had around 1,000 almiras. Okay, so now you can imagine that to find those kind of books, it was difficult. Oh wow, many people had. Interesting. Yes, that's right, Sukhvinder. They put labels starting with alphabet on the book shelf itself. But we had a separate catalog. We had separate shelves containing only the catalog. One was by the book name, other was by the author name. And it was really time consuming to find a book. Yes. Our college had a big library. How do you know, Sneha? All right. Yes. All right. Great. So, yes. So, all I'm trying to emphasize here is that even a simple lookup is suddenly really fast. Okay. As an example, if 100 records were taking 2 seconds, okay, if 100 records were taking 2 seconds, 1,000 records would take 3 seconds, and 10,000 records approximately would take 4 seconds. So that's the magic. That is the magic of of the indexing. Okay? So if you had 100 books to search in, if it's taking 2 seconds for you, okay, in the index, if you had 1,000 books, it will hardly take 3 seconds. All right. So that is the power. That is the power of the indexing. All right. Next question is when we say select star from a table, order by name, does it involve indexing, or does it involve or get improved by indexing on name? Yes, ordering is of course sorting. So select star from, so order by is of course impacted by sorting algorithm. Now let's take a third case. Now let's take a third case. Select star from table, group by name. Now, does it involve or get impacted by sorting? Anybody? Does group by involve or get impacted by sorting? If you have to do group by, what is it that you will do? If you have to do group by, what is it that you will do? Let's say I give you list of names and I want you to create groups of the same name. Okay? So what will you do? What will you do? What will be the easiest way to do the group by? All right. So the easiest way of doing the group by is using the sorting. Okay. So group by is essentially equivalent of sorting. All right. Next is say select star from table 1 comma table 2. Here we are joining two tables, table 1 and table 2. So when we join two tables, okay, the great way of joining is that you sort both the tables, okay, like this, okay. So you join the two tables, table 1 and table 2, by the way of ordering the two tables by the column on which we are joining the two tables. Okay, so here we are joining table 1 dot x and table 2 dot y. What does it mean? How would you actually, if I give you physically, if I ask you that, hey, these are the two lists, can you please bring the user's name and their age together? One table containing name and other table containing the age. Okay, and you have to join based on certain ID. So how would you do it? What will be the easiest way to do it? The easiest way of doing it is you sort both the tables by the column on which it's being joined, and then you put them side by side, and then bring them together, bring the records together. So if you sort them, put them side by side, suddenly the whole performance, after sorting, the whole performance will be really, really great. Okay, so this is a very easy way of joining the two tables. So what is it that I've tried to prove just now? almost every command related to SQL, almost every command that is generally involved in data churning involves sorting under the hood in one form or another. So most of the in our normal data world, most of the problems could be converted into a sorting problem, into at least they are converted partially into sorting problems. Okay, as when we go forward, you will see that the very complex problems itself we will be able to break down into sorting problems. If we can break down into a sorting problem, the problem becomes solvable. If we can't break down a very complex problem, as in a problem that requires many iterations, if we can't break it down into a sorting problem, then we generally can't solve it. Okay, so therefore, a sorting problem is a very important one to solve. And you will be amazed at how many algorithms exist for sorting problem for exactly the same reason. For okay, for exactly the same reason. All right, brilliant, brilliant. So yes, so all I've tried to explain is that most of these technologically challenging problems involve sorting in one form or another. And therefore, the reason we have kept the, sorry, that is the reason why Hadoop is basically a big mammoth sorting engine. It sorts data using so many computers. All right, that's what is MapReduce. We'll go into the details bit by bit. All I want to do is bring your focus to the sorting algorithms right now. Okay, so all right, so we will discuss MapReduce. All right, but before that, let's try to understand how to get the work done using many computers. Okay, in Hadoop, you get the work done using many computers. All right, and then we will talk about how to break down your problem into a sorting problem and into MapReduce. Okay, we'll try to solve a couple of problems, and then all right, so the lower bottom part here, this one we have already discussed, right? There is admin node or name node, then there are data nodes, they're storing data. Now, interestingly, in Hadoop, since these computers which are serving the data, which are data nodes, are comparatively free processor wise. So on all of these nodes, we install a process called task tracker. And on one of the nodes, we generally dedicate as job tracker. So job tracker and name node, although they are installed on the same machine in this diagram, but in real life, they are generally on different machines. All right. So I take a step back. So to get the work done by using many computers, Hadoop uses something called MapReduce engine. This is the version 1.0. I want to first talk about version 1.0 and then we will talk about 2.0. Okay, the reason why I'm talking the older version first, because it makes the life easier. It makes easier to understand. In MapReduce 1.0, MapReduce did the computing in the following manner. First, in Hadoop, what they did was they made sure that the work could be divided into multiple machines. Okay, so what they did was they created master and slave kind of architecture, just like Hadoop, HDFS. In HDFS, you have one master and rest are just storing data. Here, there is one master and we call him job tracker. Job tracker basically does nothing but interfaces the customer. So if you want to get something done from the job tracker, you will ask job tracker to do things, and job tracker will assign the work to the task trackers. Okay, to the task tracker, and task trackers will finish their work, and once they are done, okay, task trackers will finish their work, and once they're done, they will store their output in HDFS. All right. Now, question. There are many questions at this point. First, so we are running task trackers and job tracker. We talk to job tracker. Job tracker is delegating work to the task tracker. What happens in the case that so whenever we give the work to job tracker, it gives the work to task tracker. Okay. Now, first question is, does every processing get done on all the nodes? No. Only the nodes which are near to the data. Okay. The other way to look at the model is, there is a client. Client goes to job tracker, hands over the work, and job tracker gives the work to task tracker. Okay. All right. All right. So job tracker gives work to only those task trackers which are nearer to the data. Okay. So these are the data processing works. Some of most of the works are basically related to processing certain data lying in HDFS. Okay. Although there are some works which do not require any data processing, those kind of work get done on the choice of the job tracker. Okay, so there are many considerations which job tracker does while assigning the work. First, which one is closer to the data? As we already discussed in the previous sessions, that data gets stored on the data nodes, right? Data gets stored on the data nodes. Every machine is having some part of the data, and when we run a logic, what happens is the logic goes to only those task trackers which are running very close to the data. Okay, very close to the data. So there might be multiple data nodes, but only those will be utilized which are closer to the data. Second consideration while assigning work is, which data node is more busy. If data node 1 is busier than the data node 2, since job tracker is keeping track of the jobs, okay, next job will not be given to the job tracker, instead some other node nearer to the data. And in case one task tracker does not respond, job tracker assigns work to somebody else, and that somebody else will start working again. And in the same way, if some other task tracker fails, the work will get delegated to somebody else, and that's how the whole job tracker task tracker philosophy works. Okay, let me check the question and try to answer the questions. All right. So Anand's question is how HDFS handles multiple source where source order is different. For example, DB2 sorts in a different order and SAS does it differently. So Anand, HDFS doesn't care about any of this. The way your local file system C colon D colon can store anything you give it to it. Okay, it doesn't matter whether the data is from DB2 or some other place. Okay, so for HDFS it's just a file system. Did I understand your question correctly? Rajiv's question is, does job tracker talk to name node? Yes, very good question. Yes, therefore job tracker should know about the name node. All right. Yes, Satyan, your question is right. Yes. So another way we can say that job tracker is a supervisor. Yes. Okay, that's correct, Ashok. Sneha's question is, how will I get to know which data is nearer to the data? Which node is nearer to the data? Based on IP addresses slash configuration. Okay, when you set up your network, you define the topology of the network, or if you do not define the topology, it will infer the closeness of one node to another based on IP address. Very brilliant questions. Another question from Prabhu is, will there be a situation one job tracker could not handle and split the task with one another job handler? No. So the way it would handle is, in these cases, that the job tracker is generally singular, as in there is a single machine which is handling the job tracker. Okay, but those kind of scenarios what you're talking is very important and have been fairly taken care in case of Hadoop 2.x. All right, those have been considered in case of the newer version. All right. Parvez's question is, please elaborate more on near to the data. Okay, so if in a data center, how do you have the data center? Okay, I'll try to explain to you. I think that's a place where everybody is confused. I would generally try to show you. Okay, so in a data center, you have these racks. Okay, you have these racks, and every rack has computers in them. Okay, every rack has computers in them. Okay, similarly here, like this. Okay, these are the computers, and here there is generally a router. Okay, here there is generally a router. Okay, there is this one router here, and then you have another router. All right, so you basically connect all of these here. Okay, let me take a pen instead. So you connect this one here, and this one here, and this one here. So this is one rack. This is rack one. Okay, and rack two. Okay, so this router actually is generally part of the rack itself. Okay, and all these nodes are connected to the like this. Okay, then there is some other router, okay, to which both of these racks are connected. Okay, so basically if you see, since this rack, all of the computers are connected to the same router, if the data node and the task tracker are on the same rack, they are nearer to the data because they're connected to the same router. The data does not have to go through here over the cable. It's on the same node. Okay, but this, if data is here and you're processing here, the data will have to be transferred till here, right? And therefore the it will become slower. All right, does it explain nearer to the data per base? All right, I think I'll include this slide here. Let me just put an example. All right, let me just put an example. All right, all right. Does task tracker work on replicated blocks? In case of these blocks are needed? Yes, wonderful. Thank you, Abu. That's a good point. So, in case the node which is containing the first block is busy, okay, it can go to any other machine having the copy of that block. Okay, all right. Vishnu, does that answer your question? All right, all right. There's a question from Prabhu. Task. This is a brilliant class. I think I'm getting a great set of questions from you. Okay. Tasks like sort million records of citizens by age group. Will this task be split into multiple task trackers and then final output will be merged? Brilliant. Yes. That's where that's what MapReduce is. Okay? Okay. So Vishnu's question is, will each data node have a separate task tracker? They may or may not be. Alright, I'll explain to you why. So what you see here is these are processes. So this one is a computer, this one is another computer, and imagine that you have here five computers. Okay, the way we have H1, H2, H3, H4, H5. H1 we are running job tracker and name node. On H2 we are running task tracker and data node. These are just processes. It's not mandatory that every node in your cluster has to have data, as well as there is no mandate to have task tracker on every node. Okay, it's up to us. All right, a question from Ashwini. Each data node is assigned a task tracker to handle the data. Yes. I mean, again, the same question. So generally, I'll be political. Generally, yes. Okay. Question from Suraj. Does the job tracker look at which data nodes are busy or which task tracker are busy? They look for which task tracker are busy. Okay. because it knows that. So job tracker knows exactly which machines it has assigned and which have not responded back. All right. We have a question from Sukhvinder. All right. So generally, as in our normal practice, we generally do not worry about this part. We let we let the task job tracker decide what goes where. We just tell that, hey, we want to process this data, and here is my logic, and it will figure out where is the data located, where is the copy of the data located, and out of these, which machines are most free. Okay, and if all of the machines are free, then it figures out based on the past history of the machine that how many tasks have failed. Okay, so which one has not failed much, it will pick up those. All right, so it basically also keeps track of matrices of the past history of every task tracker. And in the worst case scenario, if it does not find a task tracker near the data or on the same node as the data, if it does not find a task tracker available, it will assign to the second node. If first it will try to find out if my data is here. Let me just fill this thing with say, where is that thing? Okay, okay, if my data is here, okay, if my data is here, and so first it will try its best to allocate the task tracker on this machine. If task tracker is not available here, it will try to do it here. If it's not available here also, either of these three, then it will go to another machine in the cluster and will try to say execute on this one. It will try to execute the logic on this one. Okay? So it tries its best not to deny the work. All right? So Anand's question is Hadoop 1.0 being used now? Not. Okay, the only reason I'm discussing it because I want to take you through yarn. Therefore, I want to keep everybody on the same. You know, since I want to take you into describing yarn, it'll be very useful to understand this kind of architecture. All right. Parvez's question is: router is the first compartment in the rack nowadays. Yes. Thank you for that, Parvez. All right. Some of the racks have the router in the basement. All right. Very good question, Prashant. Prashant's question is topology inferred or is manually fed? Okay. So there are two ways to do the topology. We have been talking about two things. The data locality. We have been talking about data locality, and then there is a rack, then there is this, then there is that, right? So we are trying to describe the locality. Now, question is, does Hadoop automatically figure it out, or does it rely on our configuration? Quick answer is it relies on our configuration. Second question you might be having in the mind, is there any system in the world which will try to find out the data locality by itself? Yes, there are. Okay, yes, there are. For example, MongoDB. Okay, MongoDB automatically figures out topology. Basically, it does not really figure out topology, it just figures out which nodes are closer to which one based on the ping response time. There is something, a command called ping, using which you generally debug your networks and using which you also figure out which computer is faster and is more responsive than the other. Okay, so the nearness, the idea called nearness could be done in two ways. First, you configure it. You define that this node are closer to each other, or are the parent, are the siblings, and these nodes are the distant cousins. Okay, so this is something you do in Hadoop, while in certain systems the system itself keeps on pinging each other and tries and figures out which one is closer to which one. But Hadoop chooses configuration over automation. Reason being that automation is quite network intensive. It kills the network because every second it has to keep pinging all the network. Yes, there is a mapping for it. We will consider it when we discuss the topology. Good, the topology part is covered now. Yes, that's right. You may consider task tracker and, and name node and everything is a service. Maimona's question is MapReduce the job tracker? No. It it is a process which involves job slash task trackers. All right, it involves job tracker and task trackers. It's a big process. I'll come back to it. Very good questions. I think this is a great exercise happening for all of us. When a data node fail, the same name node come to know via job tracker or direct. If the data node fails, so anyway, these name node keeps pinging data node frequently. If it doesn't receive the pings from data node for quite some time, then it assumes that the data node is dead, and then it starts moving data to some other machines. Okay, in a similar way, task tracker keeps getting the pings from task tracker keeps pinging, all the task trackers keep pinging all the time the job tracker. In case job tracker doesn't receive the task tracker's ping, it assumes task tracker to be dead. Okay, so you define that's how you define that's how you define the that's how you divide the work amongst multiple machines in a cluster. Okay, so there is a master slave concept. All right, so Anand's question is that regarding the million record, in case the data is lesser than 128 MB, okay, okay, it's less than 128 MB, then it will be on one machine. Then also the task trackers will work only on one machine. Okay, the combination would not be required. All right, Sukhvinder's question is, these are very brilliant questions, I must say. Okay, so everybody should pay attention to it and try to answer the questions by themselves, and then, okay, that means job tracker creates task tracker and assign works to the machine and talks about the status of work with the task tracker. Yes. So the only difference is job tracker does not create task tracker. Task trackers is running as a process on every machine, and job tracker is running as a process here. Job tracker talks to all the task trackers and creates tasks for everyone. Okay. All right. Okay. Prabhu's question is, does task tracker, job tracker setup depends on kind of solution we implement, or in a cluster setup, this configuration comes by default. So in Hadoop cluster, this is by default. When a data node fails, the name node come to know via job tracker or direct. Okay, so I said direct. All right. Next question is, can a data node have more than one task tracker? Can a data node have more than one task tracker? Okay, generally no. Okay, so there will be always one task tracker. This task tracker has the ability to perform multiple tasks in parallel. Okay, and how many multiple tasks each task tracker can handle, we can configure that. Okay. So Maimona's question is that if all the task trackers are busy, does it prioritize tasks? Yes. Okay. It does. It puts it in the queue. It has something called a queue concept in the newer one. All right. Great set of questions. All right. Question from Sneha is: after completing the task, does task tracker gives ACT acknowledgement to job tracker? Yes. Okay. It basically updates a file called underscore success. You will see that when we talk about later. Okay. All right. So basically, there are multiple ways in which it informs the job tracker. Okay. One of them is updating a file. Another is by using direct communication. All right. All right. A question from Aswini. When the data node fails, data will move to other machine, which means computers which are not on the same cluster share the data, or do we need to add a new computer as a data node? Okay, so in case one of the data node fails, okay, and data will move to another machines, that's true, and that's true. Up to here, it's completely true. Okay, so data will move to another machine, which means the computers which are on the same cluster will share the data, or do we need to add new computers as data node? So it all depends. Let's say you had 20 computers, one of them has died, okay? The data which was on that node has vanished. So the blocks will be replicated more on other machines, okay? The blocks will be replicated on other machines, and the blocks will be replicated on other machines as well after it has died. Okay, at this point of time, your MapReduce will not fail. They will succeed if you are churning the data which was there on that node, because it has been copied to another nodes, or it's being copied, and other blocks which are the remaining two blocks out of the three blocks remaining two blocks will be processed. Okay, but in case your cluster is overloaded, all right, in case your cluster is already overloaded at 19 nodes, you might have to add one more node with some data node and some task tracker. Okay, now Satyam's question is, let's assume that our 1 million data is less than 128 MB, so one block is required, and but our replication vector is 3. In this case, will MapReduce run our logic on 3 nodes to speed up the work? Okay, in this special case, the MapReduce gives you the ability to specify. Okay, it will run by default, it will run on one machine, but you could to force it to run on another machines. All right, okay, think about a situation, Satyan, that let's say you are trying to generate all possible combinations of DNAs which might fit into a particular configuration. So you are trying all combinations, right? You're trying, or think about this way. You know a system, you know the hash of a password, and you want to crack the password. And all you need to do is keep trying all permutations, and then encrypt every permutation and compare with the encrypted one, or compare with the hash one. So the way generally password system work is, you do not store password on the server. Instead, you store the hash. Hash is a signature of the actual string. Okay, coming back to it. So let's say you forgot the password and you have a great cluster which can crack the password, and you know that your password is out of a big dictionary of few billion records. Okay, few million record, let's say, or your password is a combination of the dictionary plus some more characters. So what you do is, you divide the dictionary amongst the cluster and force the cluster to run on more nodes than the data, because the dictionary may be small, dictionary may be few hundred MBs. Okay, maybe 100 MB, and then if it's only 100 MB, there's a single block and it will run on one machine only, one data node is impacted, so one task tracker will be impacted. But the new job tracker, which is Hadoop.x, allows you to send as a configuration parameter number of machines you want. If you want 500 machine for 1 KB data, that's completely okay. And one such example, as we go ahead, one real example will be a tool called Scoop. Scoop pulls the data from MySQL into Hadoop, and there it does the distributed programming. It pulls the data from a third party into Scoop, and there is no HDFS involved. The way the work is divided in case of Scoop is not based on how much data is involved, but based on the configuration which user supplies. Okay, so I hope that is clear to you now. Very good question. Okay, Asmit's question is, how do we set priorities of the task? We'll talk about it. So admin can create tasks on queues, and we can give the priority to queues. Rajiv's question is, what time replication starts? At the time of moving the data to nodes, the first time, or the time when machine or data nodes go down? Okay, answer is both. So as soon as you copy the data to the node, when you try to copy the data to the local node, let's say we all the time we are saying Hadoop FS copy from local. You know what's happening? It's only copying the data to the node on which you are standing, which is H5 data node. Most of the file which we're copying, first block goes to H5 data node. And then H5 data node starts replicating it immediately to all the machines. As well as if H5 goes down, it will start replicating immediately. Or some H4 goes down on which we have some data already, the same data will start getting replicated. Okay, because the moment one machine goes down, it loses the ping, it loses the data. Ping as in it will not ping the name node anymore. So it reduces the replication factor of all the blocks that are lost by one. All right. Next question. Good question, Rajiv. Does each data node have a task tracker associated with it? Can one task tracker be associated with multiple data node? Okay. First, there is no association between task tracker and data node. These are two independent processes running on the same machine. Every time we ask, every time we ask the job tracker that, hey, can you get me some work done? And this work involves this file. The, the job tracker first talks to the name node and finds out where is this data located, and it handovers the IP addresses. It handovers the IP addresses to the job tracker that hey, your data, the data you're trying to churn is stored on these machine, please use those machine. Okay, and you say that hey, I don't care where my data located, just give me 20 data node 20 task trackers and please get the work done. Okay, so there is no association as such. Anand's question is, does the scoop work with MySQL or does it every DB that supports JDBC? Okay. Okay. A question from Sneha. Do we use scheduling algorithm to determine priority of the data? No. We don't generally prioritize the data per se, but we prioritize the processes. Okay. So question from Anand is, can we schedule jobs in Hadoop, or in other words, run a KSH file? Anything, anything that runs on a node on a computer can be run inside Hadoop. We'll show you this, okay? Very great set of questions. I think this is a good way to clear your doubts. Okay, if my understanding is correct, one task tracker can work on data from multiple data nodes. One task tracker can work on data from multiple data node, and multiple task trackers can work on data from multiple task trackers can work from, yes, true. Okay, that's right, Prabhu. Thank you for this. All right. Great, great. I hope everybody's doubts are clear. I hope I'm not rushing. Okay, so feel free to stop me because sometimes I start rushing unnecessarily. Okay, there's no reason to rush into anything. Okay, unless the things are clear. If I move ahead and your doubts are not clear, rest of the topics might black out for you. Okay, because not because topics are dependent on each other, but because you might feel awkward. All right. So keep asking question. If it's not clear, I would like to explain it in detail. Okay. All right. Let's take a break for 10 minutes. All right, so I'm back. Should we start now? All right. Okay, so let's start. Is everybody back? Sneha, are you back? All right. All right. Vivek's question. Okay. The last question, you mean this one? One task tracker can work on data from multiple data nodes? Okay. All right. Is everybody back? Should we start now? Yes, Sneha, I was about to answer your question. So that's the reason I was thinking that if you're wrong. All right, all right. Let me answer this question. So, Sneha, when you're back, just let us know so that I can answer your question. Okay, now, question from Vivek is that my answer to this one is not clear. Okay, this is a little tricky, but let me try to explain again. Okay, so here when I drew, okay, when I drew this, okay, here there is task tracker and data node. Okay, so Task Tracker is a program. Think of Task Tracker as any program. Say it could be, let's say, what is the best form of command line do you use? Okay, let's say this Task Tracker is counting number of files. Okay, let's say the role of Task Tracker is to count number of lines in a file. Number of lines, count number of lines in a file. Now, and we told the job tracker that here is a big file. Please count number of lines in this file. Now, job tracker took this information from us. Okay. The problem statement to the job tracker from our side is that hey, here is our big file. Here is our big file, and can you just count number of lines in this big file? Okay. Now, job tracker will find out how many blocks are there, and then it will find out all the blocks of that file, and then find out task trackers closest to the free task trackers closest to the data. Free task trackers, all of those free task trackers which are nearer to the data, it will find out. Okay, and then execute the logic, as in the logic says find out number of lines in each file. Correct? So on the prima facie, it might look that the task tracker is working on only data from the single data node, but in reality there could be many scenarios. One scenario could be that our data is very small, but our work is too heavy, such as cracking the password. The dictionary was small, but cracking a password requires generating all possible passwords and then trying all of them. So the work was too heavy, though the data was very small. So if task is only run on one data node where the data is there, then it is going to take a long time to get it done. So if your data is small and your work is heavy, then you might need more task trackers, right? More task trackers than the data. Therefore, there is no one-to-one relationship between data node and task tracker, which means a task tracker, there could be multiple task trackers running on a cluster while the data is only on one of the nodes. Okay, it's just uh, all the task trackers are accessing the file from accessing the same block from the HDFS. Okay, there could be another scenario. There could be another scenario whereby there is a single task tracker accessing data from all other nodes. All right, so there is no, I mean, and this mechanism will vary from work to work. Based on the kind of work, job tracker will take a call whether it has to create 20 task trackers or 10 task trackers corresponding to the same data. All right, this is an important aspect. Good. Vishnu's question is the resultant data will, after processing, will be stored in the same data node? Not necessarily. It will depend on what are we trying to do. Okay, all right, let's move on. I think everybody is on the, okay. Vivek's question is, so it is sort of load sharing mechanism based on size slash speed. It is sort of load sharing mechanism based on size and speed. Yes. All right. So number of task trackers is all depend on job tracker. I mean, job tracker creates many task trackers at once and job tracker makes those calls. So we ask job tracker, we force job trackers. The default behavior of job tracker is to create only those many task trackers which number equal to the number of blocks. Okay, we will go into the details when we talk more about the exact behavior. Okay, right now if I try to explain input split and other things, you might get confused. Okay, so yes, so job tracker can take a call or we can ask job tracker to take that call. All right, Sneha, are you around? Can I answer your question now? All right, good, so she's back. All right. So what is the replication factor? Replication factor means number of copies of a particular data. Okay, particular data block. So a file gets uh, broken into say block one and block two. Okay, let's say you have 500 MB file, and first one is 128 MB, and not 500. Let's just say 200. Okay, 200. And second one is how much? 72 MB. Okay, these are the two blocks, and every block one will have copy copy of copy one of block one. Okay, and copy one of block two, and so on. All right, so this one is 2, this is 3. So this means there are 3 replication factor. All right. So this is 4. Okay. This is 3 replication factor. Okay. If this file is of 200 MB and what we have uploaded and set the replication factor as 3, then this will happen. Okay. You will have total number of 3 blocks. Make sense to you? Okay, so whenever we say replication factor 3, meaning total number of copies of each block of that file. Replication factor is specified in two ways. First, while installation or during from the Ambari, we can change the number of replication the replica factor. Okay, replica factor states how many copies of each block are going to be there. So for example, here we are saying replication factor is 3. That means this file is of 200 MB. It will be sliced into two blocks, block 1 and block 2, and each of these blocks are going to be replicated so that total copies are 3. You see that? All right. So block 1 has been copied. There are 2 copies of block 1 and there are 2 copies of block 2. Alright, makes sense, Snehana? Alright, good. So this is the replication factor. So let's say this node containing these two or maybe let's say this node containing this particular block is dead. Okay? So the from this copy, another node will be created, okay, with the third copy. Okay, the data from this block or this block will create the third copy. All right, this is just identical. These 3 blocks are identical. All right, so that's one way. So you could specify the replication factor in general for the whole file system. Whenever people are creating a fresh file, you can specify the default replication factor. For example, in our case, the default replication factor is 3. Okay, and it's safe to keep 3. Or you could change individual files replication factor to something else. All right, there are few questions I need to answer. All right, a question from Asmeet. Question is, you say earlier task tracker is independent entity and job tracker not create task only. You said task tracker is an independent entry and job tracker does not create task tracker, only create tasks. Yes. So it's not independent in the sense that um, see, the role of task tracker is to execute tasks assigned by job tracker. So job tracker would basically talk to task tracker which is running on the nodes and then assign the work to the task tracker. So task tracker and job tracker both are long running processes. Okay, they keep on running in the background day and night. Parvez's question is, how job tracker decides to engage number of task trackers? Is there any algorithm which gives the overhead required to the process? Okay, we will dive a little bit more after I describe yarn. Okay, that'll give you a little more clarity. All right. Okay, question from Ashok. Who would decide the block size? Block size is also configured in the system. Okay, you can change the block size, default block size. All right, good, good. Now let's move on to the next level. Okay, so everybody understands as of now that what does it mean by job tracker and task tracker. Although it looks ugly, but this is useful. Okay, so now let's talk about the job tracker. This is done. All right, this is a very quick overview. Don't get into nitty gritties right now. This is just to give you an overview. We will go into exact semantics again. So a user submits this. This used to be the old MapReduce way. Okay, so the user submits the job after he has copied the data to the file system. So again, most of the MapReduce computing was about churning the data which is already stored on the cluster. Okay. So the first step for the user was to upload the data on the file system, and then second step was to submit the job referring to those files. And then this client means client driver, the command called Hadoop, okay, will find out the information about the files, will then submit the job to the job tracker. Okay, and then the job tracker will create maps and reduces, put them into job queue, and then get the work done over the cluster. This map reduce you can ignore for time being. I will take a detailed consideration into this. So the client driver called Hadoop will assign the work to job tracker. Job tracker will further assign the work to the task tracker by the way of defining queues. There are multiple queues for tasks, and and for each queue it creates, for each task it creates kind of slots. If you have gone to restaurant and you place an order with a you place an order to the waiter will take your order and put it into a slot, while once the cook has prepared the food, it will bring it back, bring the food and put it near to the slot, which waiter will bring from the slot to you. Okay, in the same manner it creates something like some data structure in which every task status is marked, whether task is working or not, whether basically it's the status of the task that is maintained by job tracker. In case any of the things fail, job tracker will assign the same work to somebody else, and heartbeats are sent to all the task trackers continuously to monitor whether they are up or they're down. All right, again, so client asks job tracker to get the work done. Job tracker further delegates to task tracker, and client can ask that he needs 20 task trackers or 5 task trackers, and client, that is optional. By default, the number of task trackers dedicated to a job will be decided based on the file. All right. Now, earlier what used to happen was the logic as well as this. So just now what we saw, whatever we saw was that there's something called map reduce, there's something logical, as in the way of doing the operation, like the way when we execute some logic on SQL server, we give SQL query, right? When we execute the logic on SQL server, we give SQL query, right? So, and that query gets executed in whatever manner. In the similar way, When we used to talk to MapReduce, we will structure our logic into map and reduce. Okay, so we would structure our logic into map and reduce and we'll give it to the job tracker. So earlier in Hadoop 1.0, there was only one kind of logic allowed called map and reduce. Okay, and everything was being done by this framework called MapReduce. The same framework was doing the job tracker, task tracker, as well as at the same time it was doing the MapReduce. So everything was only in one form. So you could not do computing of any other form than MapReduce. It's like saying database saying, hey, we only allowed SQL. We don't allow any other kind of system. Although the things like job tracker, task tracker were of very much use for many more systems. Okay, many more systems. Because what does job tracker, task tracker do for you? Job tracker, task tracker make it happen that get anything done through us. It does not enforce. Job tracker, task tracker is a flexible architecture. It can accommodate all kinds of computing requirements. Okay, therefore this map reduce was very limiting because it was a single system containing both, and this job tracker, task tracker was being only used by map reduce kind of jobs. Okay, therefore it was monolith, meaning a single system which is non-separable. Okay, and that's where people from Yahoo decided to break it down into two parts. One was called pure MapReduce. Okay, one was called pure MapReduce, and other was called Yarn. Okay, it's earlier it was as if the somebody has bundled operating system with the database. Old MapReduce was as if somebody has bundled MapReduce sorry, database along with the operating system, and this system says that, hey, I can't do anything else other than MapReduce. So that was MapReduce 1.0, and that got broken down into two parts. One was called MapReduce, pure MapReduce, just the data processing using MapReduce. Other was called Yarn. Now this refactoring, this is basically refactoring. Refactoring means breaking a larger piece into two smaller pieces. Okay, this refactoring allowed lot of innovation to happen. Now you are not happy with MapReduce, you come up with something else. Okay, somebody needed a kind of Spark and they wrote Spark. Then many more innovation came in the form of MapReduce, similar to MapReduce. Now you can see that as soon as that happened, as soon as this resource management, like which task tracker is free, which one is busy, tracking all of that was taken out and put something into Yarn. Now Yarn contained only the logic that involves assignment to task tracker, assignment to job tracker, and so on. So it's like we have taken the operating system out and made it available such that this operating system can execute everybody's programs, not only of a particular party. Now this opened the door for a lot of innovation, such as the MapReduce was anyway there. These is an alternate to MapReduce internals. Then HBase. HBase amazingly runs on Yarn. Similarly, it opened the door for Storm, Giraffe, and Spark. Spark is continuously competing and changing the way people did MapReduce. Okay, people are moving to Spark as of today. We will cover full 3 hour session of Spark, a proper hands-on version. Okay, and so there are many more systems that came because of breaking the MapReduce and separating out MapReduce from Yarn. Okay, so what does Yarn do? Yarn provides you a way of executing your logic on many machines. machines. Any program you give to Yarn, Yarn will launch it on many machines. Okay, all right. Yarn will execute that into many machines. Okay, and from the you will assign the work to Yarn, and that's it. All right. All right. So again, Yarn supports workloads other than MapReduce. It provides you the scalability. An interesting part was that whatever older programs of MapReduce were there, they were comfortably running on top of Yarn. Okay. Let me recap a little bit. So when we talked to MapReduce, so MapReduce contained everything. First, it contained all that task tracker, job tracker kind of model where job tracker was doing tracking the task trackers and getting the work done through task trackers. Plus, when we assign work to job tracker, we were only able to assign the work in the form of map reduces. We provide two piece of logic we used to provide in MapReduce 1.0, we could only provide two pieces of logic. One was called mapper, other was called reducer. And that logic was run by job tracker and task trackers such that you get the results. Okay, mappers were run on all the nodes, and once the result was produced by mappers, it was gathered together, and then reducer one run on the aggregation. Now, interesting part was that you could only program on Hadoop cluster using MapReduce earlier, and that's what was broken by Yarn. In Hadoop 2.0, the same MapReduce became Yarn plus MapReduce. Okay, the common part, the common resource management part. See, as you just saw that you have so many questions related to resource manager. Can it handle this? Can it handle this? Can we say that use 10 task trackers? Does it track which one is busy, which one is not? Does it track which one is closer to data, and so on? So from the discussion itself, the purpose of a resource management is is very high. The need of a resource management is really, really high. And that's where the need of Yarn was there for all of the other people. Okay, so it made it possible. This Hadoop had Hadoop 2.x was not in place. Today, the need for Hadoop would have been very, very limiting. Okay, so whatever we called job tracker in MapReduce 1 became multiple things in Yarn. One is called resource manager, other is called application master, and then it's called, so job tracker became resource manager, application master, and timeline server. And task tracker became node manager, and slot became container. Slot as in individual tasks slot. Okay, now here is a little complex diagram. All right, it's as if there is a country. Okay, I'll try to draw this. I think that will do a big magic. Okay, all right, let me just. Okay, so let's just take an analogy. Wow, there are so many questions. Okay, let me just let me try to give you an analogy and then I'll take up your questions. Okay, so I'm trying to explain how does Yarn work. Earlier we discussed how does MapReduce work. There are mapper, there are task trackers, Okay, so there are, in case of MapReduce 1.0, in the older system, there was job tracker and task tracker. In here, we have different things. We have resource manager, and then there are multiple nodes. So on each node, we have node managers. And whenever client comes along and says, hey, I want to get something done, so client has also have to tell us that what is that something they want to get done. He says that, okay, my work is related to this new framework and I know how to get my work done. So resource manager says that can you give us kind of a logic? How would you run your system? Okay, so client will also give the complete logic to the resource manager, and that logic would be run in something called application master. There is an application master for every kind of consumer of yarn. For example, there's an application master for MapReduce, there's an application master for Spark, and so on. So application master is kind of the representative of the framework which we are using. Client want to use some new fresh framework which is not there on yarn, they can submit their framework along with that, and that framework will be run as application master. Okay, it's a kind of a government. It's a kind of a government that government says there is a PM office. Okay, I'll just try to simplify a little bit, and then there are states. Okay, these are, let's say, two states. Okay, let's say some two state one and state two. Okay, now Microsoft comes along and says to PM that, hey, you know what? I want my Windows to be built in your country. Can you devote us some location and resources? PM says, okay, I don't know how to build your Windows, but I know that there are people in these two states. Why don't you go and establish your office? So Microsoft goes and says that here is my headquarter. Okay, this is kind of Microsoft headquarters. Okay, and that's kind of application master. Okay, I'm trying to take an analogy. Don't get offended in any way. Okay, and all right, now this is the headquarter. Okay, and then there are people working at various places. Some people here. Okay, some work is being done in KA, and some work is getting done in AP. Okay, Microsoft headquarters know how to get their work done. Okay, there are workers here and here. That's what is happening. So the client, which is Microsoft, came to PM and said that this is what we need close to 1,000 people, and we need close to highly educated people and one office. Okay, so this is what happens. All right, in the similar fashion, some other company, say Amazon, comes along. Okay, some Amazon or say GE comes along, and GE says that, hey, we need five headquarters. I mean, also in case of yarn, there is always one headquarter, so let's settle it down. Okay, so instead of earlier in Hadoop 1.0, this guy, the job tracker, was trying to get everything done. In new case, the client also submits the application master. Okay, so Microsoft came, talked to PM, and said, I have my people who are supervisors and the directors and everything. Okay, they will be my application master. I'll get my work done. Just give me a place to stand and the resources. Okay, so this is an analogy to what's going on here. So the client comes and says, hey, I want to get my MapReduce work done. Okay, so resource manager talks to these node managers, and here node manager means the chief minister of the CM of each state. Okay, CM of each state. I thought about this analogy. This analogy is actually fitting very much. So this resource manager talks to each individual node manager and says, hey, we need 5,000 people. Do you have 5,000 people? And and then node manager says, yes, yes, we have 5,000 people. And resource manager also says that we need one dedicated office for the headquarters, and that becomes the application master. So every client, okay, in case some other Microsoft users come in from outside, they will also be redirected to same application master. So every framework comes with the application master, okay, along with the need what they want to get done. All right, so this is how it works. All right, let me take few more questions, and then I will deep dive into this, or let me just describe once more so that all of us are on the same page. Okay, all right, so okay, so here it is. The node manager is per node agent. It's like chief minister of the state. These are states: state 1, state 2, state 3. This is the country chief. Okay, so the node manager here is per node agent. It manages and enforces resource location allocations. Okay, then there is application master. Application master are per application. Today it's Microsoft which came in that my work needs to be done. Then after some time the Wipro came in that hey, my work needs to be done, and so on. So this application master is only one. There is only one headquarters, okay, who manage their container, as in their journal offices. All right. So application master manages the application life cycle, okay, and also takes care of all kinds of work scheduling. In case so, if we are running a map reduce task, application master will be deciding how many maps, how many reduces, and so on. Okay. All right. So the way it happens is the client submits their application. Client not only submits a small query or the logic, it also submits the full application. And this application brings the logic that needs to be done inside application master. So client submits the app, resource manager launches the application master inside the container. Okay, and so the client submitted the resource manager. Resource manager consulted with all the node managers, and whichever node manager can run application master and is most free, that machine, that node manager, that node will be given the application master. Okay, so it's like setting up the headquarter in the state where the taxes are lowest and there is a lot of land available. Okay, now, okay, so And container is a form of office. Okay, so no matter what you do, the work always gets done inside container. Application master is also running inside container, so everything gets done inside container. So resource manager launches application master inside a container, and then application master registers with the resource manager so that the users of this application master can contact it. Okay, all the users of Microsoft can contact this headquarters. Okay, all the people who are coming from US or somewhere, or who are going to the US, they can talk to the headquarter directly. They don't need to establish the headquarters again. Okay, so the application master asks for the containers, and they get it. So again, once you establish the headquarters, they will again raise a request that, hey, we need 20 containers, as in 20 more smaller offices in the country. Okay, give us those. And once and then those containers would be availed by various node managers. And once that is done, okay, the the application in the container talks back to the application master. So any work that is getting done for this application master will get done inside various containers. Okay, and these containers will talk back to application master, and then client can talk to the resource manager and talk to the application master and take the status as what's going on. Okay, and once everything is completed, application master deregisters itself from the resource manager, and get out. Okay, and shut down. All right, so that was a way of understanding yarn. All right, so you can look at the other way as well. So application client submits the work to the resource manager. Okay, we are submitting the yarn application. All right, and the prime minister, the resource manager is assigning the work to the node manager, and node manager is creating a container for the application master. An application master registers back to the resource manager, hey, I'm up, and then starts working on actual work, start focusing on the actual work at this point. And what does it mean by actual work? Actual work means node manager and the containers. I mean, more containers will be created for each application master, and that's how it goes on. All right, so a resource request, when you are asking, when a client is making a request to the resource manager, it's create something called request. It's called resource request. And resource request could include, how many containers do you want, how many memory of each container, and how many processors do you want. Okay, along with that, do you have any locality constraint, meaning, do you want to enforce that your containers should be only on the node where the blocks of a particular files are available? That is locality constraint. So when you are making a request, you could tell, hey, my work is very heavy, I would need so many containers, and I would need so much memory on each container, and I would need these many total CPUs. Along with that, you could tell Jan that, hey, my request to you is, please run my logic near to this particular data. That is locality constraint. You could make the request of all these resources upfront, as in, you could make this request to resource manager directly, the client could make it directly, or let my establishment start, and then the further requests could be made by application master. Further requests could be made by the application master. Okay, so that is either you could ask for upfront while from the resource manager, or you as in the client might ask the resource manager, or the application master would ask for number of containers. Okay, now the application's lifespan could vary too dramatically. It varies too much. There are some applications which keep running forever, and then there are some applications which run only for few seconds. Okay, so generally the lifespan of a process is of three parts. Okay, just one application per user. Other is one application per workflow, meaning you started a session, keep on working, and then the third one is long running. All right. So if you want to build your own yarn application, first try to use existing frameworks such as MapReduce, Spark, etc. Second, try to use existing tools to build jobs such as Apache Slider and Apache Twill. And otherwise, if you want to build, be aware that building from scratch is complex. Use Yarn projects bundle called distributed application if you want to build your own. Okay, going back and taking your questions now. All right. All right. So there are so many questions. So can you ask the questions again? The questions that are left unanswered. All right. Could you just copy paste your questions again? All right. First question from Ashok is, so you mean to say when we do word count, so yarn run the word count on all data node, is that correct? Not really. We provide the locality constraint also. Okay? So it won't run on all the data nodes. It'll run only on the nodes which contain the words, okay, which contains the data. Alright? So Vijay's question is, what is map and what is reduce? For time being, just because I would want to go into more and more details. Right now, it's a way of describing your program. You describe map is kind of a program, okay, kind of a logic or program which processes data. Reduce is kind of aggregates data. Okay, the way when you define a group by query, you have group by a particular column. That piece is generally called a map because map defines what is the ID, and then based on the ID the data is aggregated using the reduce function. Okay, so you can just think of map reduce as a way of expressing your logic. All right, Parvez's question is, yes, job tracker task trackers are captain and stewards. All right. So did I make sense quickly, Parvez, Vijay? All right, great. Parvez's question is Yarn the reason for fast Google Yahoo search engine? Kind of, yes. So basically, Hadoop is okay. Hadoop is the reason for fast Yahoo search engine. Okay, Prashant was saying, what? what I infer is that the application master can control any container on any node based on resource availability. Also, any node can be given application master role again based on resource availability. Yes. So application master cannot control every container. Every application master can only control those containers given to it by the resource manager. Okay, so RM is the one which is dedicating and giving the control to application master, saying, hey, here are your 10 containers, meaning we are dedicating 10 offices to Microsoft. They can get their work done in those offices. Okay, all right. So also any node can be given the application master role again based on the role resource availability. Yes, that's right. Okay. Now Parvez's question is for info, strategic plan, PMO, and portfolio department management. Portfolio department managing project management can be another example. Yes. So if you have strategic planning, you have a PMO office. And actually, I'm not aware of many structures of the organizations. I have seen a similar organization when I was working on my previous startup called T-Bits. And there we had a central, we were, one of our large customer was L&T. So L&T has a head office. Every resource allocation was done by the head office. And then head office gave us a office in their branch office. And from there, we were working with the branch office and the head office. Okay. So yes, you can kind of decide, say that. Okay. As I understand, containers help application masters to perform tasks. That's correct. Yes. Okay. Yes, Suraj. You also said that application manager master too works within container. So what is a container? A memory area or a process program or something else? It's a process program, or you can think of Java VM. Okay, so a container, you can think of container as if it's a Java virtual machine. Okay, this container is something very interesting part. So you run your any program which is run in the cluster is inside the rigid boundaries of the container, so that this application master does not leak. What if this application master or any of the works of application master started accessing the local file system directly and started manipulating the whole system, or a particular application master went greedy and consumed the full RAM? Okay, although they ask for less RAM, but suddenly it starts consuming more RAM. Who would be responsible for that? Okay, so that is the role of container. Container makes sure the application does not crosses the boundary. Okay, because there could be hundreds of situations where a malicious user could submit a very resource intensive or buggy, they might submit application master with a completely secret code which might start deleting the file from the local file system. So basically a lot of things could happen with application master, and therefore container makes sure the office, this office which we are talking about, this office will make sure. So one is head office and other are the regional offices. So those are all containers, whether head office or regional office, everything is a container. So that we are protected. So that nobody crosses the boundaries like how much memory we have given to particular task. Okay? All right. a question from Mohsin is, why do we need a container and what does it do when processing a job? I hope this got answered, Mohsin. Yes, good. All right. Next question is from Leela. Question is, how do these container are tied to the app manager? Okay, app, you mean app master, right? Application master. All right. So how do these container tied to the application master? See, so there could be two things. One, while Microsoft was coming to India, upfront it tells the Indian Prime Minister, "Can you arrange me 20 region office and one headquarters?" Okay, there could be one request, or it could say, "Hey, you know what? Just give us the headquarters. We will talk to you again about number of region office that are required. As we go, we will keep on creating based on our requirement number of offices." Okay, so that is the application master. Now, if Microsoft says that, hey, let's say a mining company comes to a country and says, the resource which we are going to mine is located in MP and these states in this country. That is called locality constraint. Okay, based on that locality constraint, only those containers will be dedicated to you which are nearer to the resource. Okay, so that's how the application master and container has the relationship. I hope, did I answer your question, Leela? Great. All right. So keep in mind that there is this whole thing sounds complicated. This whole thing sounds complicated, but when I thought about it, I realized that it's not more complicated than a democratic society. If you look at this diagram, it looks really crazy at first, but if you realize that the way a country works, or a way we understand, at least the way country works, is far more complex than this. Okay, so that's the reason I've taken the example. All right, going back to few questions. The next question is, can containers under one application master interact with another? Okay, so what you mean to say is, in this diagram, let's say these are the two container of this application master. There are three container, this. Can these three containers talk to each other? The answer is no, they don't. Okay, and it's all up to the application master, because application master is deciding what runs inside containers. Okay, so application master can decide. All right, all right, let me just add the other part of the question. Is there, okay, so containers don't interact with each other. is there a scenario is there a scenario where two application masters interact with one another? No. So they can interact. They uh, they can interact. I'll describe to you how. Okay, let's go back here. You see here. So HBase would be having its own application master. Okay, and Spark would be having its own Spark application master. Sometimes Spark might want to talk to HBase. Okay, sometimes Spark might want to talk to HBase. In that case, two application masters will be talking to each other. Okay, so yes. So the second scenario is there. Brilliant set of questions. So if I'm missing somebody's question, please feel free to ask. Okay. So this is last question from Vishnu and one question from Sukhvinder. Okay. So if I missed your question, please feel free to ask. Okay, because I had skipped some questions thinking that those questions would be answered. Okay, a question from Vishnu is, are containers created only in those data nodes which have the relevant data to process? May or may not be. May or may not be. Okay, depends depends on resource request. As I was telling you, let's say there is a mining company coming to a country, or let's say a particular company, say for example, a Ford is coming to India, but Ford wants its factory to be located near the rivers, near the river, and accordingly Ford would do the analysis and say that, hey, I want my factory and headquarter as all the containers to be near this particular river. Similarly, a process coming to Yarn could say that, hey, you know what? I want to process this particular HDFS file. Can you give me the containers which are nearer to this particular file? And and Yarn will accordingly allocate your containers nearer to the data. Containers might be the application master, or container might be the individual data node. Okay, on individual data node it would might run. All right, let me take another question from Sukhvinder. Question from Sukhvinder is, Yarn looks to me like an operating system, right? Yarn looks to me like an operating system which waits for your instruction, and based on the instructor it creates a handler for the work and once work. Yes, yes. All right. So application master is a process, or a container is individual thread. So application master is a process that is running inside a container. Okay, a container is a process. All right. Container runs various processes, and you can always think of AM as a process. All right. Question from Parvez is, how resource handle bottlenecks due to how resource handle bottleneck. You mean resource manager handles bottleneck due to all containers. All right. Could you rephrase please, Parvez? Okay, a question from Suraj. Are the tasks that run within container what comes are the tasks that run within the container what comes under the domain of MapReduce? So it could be anything. It could be MapReduce task, it could be Spark task, it could be H-based task. Okay, so it could be anything, not only MapReduce. Okay. Next is, can two different application master use the same container? No. Okay. A container is dedicated to a particular cause. A question from Vishnu is, why is it that a few processes create more than one container? Can you please explain again? Explain exact role of a container. Okay. So container is more like a local factory. Okay. Container is more like a local factory. Okay. If you look at the container here, container is more like a factory or an office. Okay. And this factory is a defined entity. It has to pay taxes, it has to not do any unlawful activities. So these container, like, you have a private limited party a company and all that, so these containers have to make sure that none of the processes, these containers make sure that anything that runs within the container remains inside the container, and anything that runs within the container obliges to the law of the land. Okay. Obliges to the law of the land, in the sense that none of these containers should go beyond what resource manager allows. Okay. So coming back to it, what was the question? Yeah. So some of the systems say, some of the say somebody is coming to a country with manufacturing unit. They might need 500 factories, right? In the similar way, if you are trying to do a very resource intensive work, and you are not dependent on a file. Okay. You are trying to do a lot of resource intensive work. In that case, your application master could tell the resource manager that, hey, I need 200 containers, or give me 50% of total containers you have. That kind of work. So some works could be very intensive, some works could be less intensive. Okay. And accordingly, the application master would ask for the resources available. Okay. And application master could also ask that, give me 20 containers. Therefore there could be many containers or many work tasks that could be done. Okay. Therefore, for some application master there could be many containers, some of the masters there could be only few containers. Okay. Did I make sense to you, Vishnu? Wow. All right. All right. Vijay's question is there an upgrade path to move? Yes. Almost everybody has moved from Hadoop 1.0 to Hadoop 2.0, and it's pretty straightforward. And for that matter, when we upgraded from Hadoop 1.0 to Hadoop 2.0, we did not have to make any MapReduce code changes. The same code of MapReduce we wrote for the previous one worked later as well. We just had to recompile our MapReduce code. Okay. So that answers your second question. There are hardly any company using Hadoop 1.0. Okay. Next question from Parvez is, how resource manager handles the bottleneck when all the containers applications managers are busy? It basically makes you wait. Okay. It puts you in the queue and makes you wait unless the work is other people have finished the work. Anyan's question is very good question, Parvez. Okay, so Anyan's question is, in case of node failure, same hierarchy of application manager along with container will replicate to a new node. With new node manager, information will send to the client by resource manager. Yes. Okay, so what happens is, question, very good question, Anian. Now here what he's saying, let's say this particular node is down, so the same work would be given to somebody else. Similarly, similarly, the the node which was running the application master is down, the application master will be recreated on somewhere else by the resource manager. Okay, in case the application master itself goes down, resource manager resource manager could create the application master on somewhere else. All right, brilliant question. Okay, so that was a brief overview of yarn. This is very important to understand, at least the analogy which I have given you, that this guy, resource manager, is like a PM. Client could be the CEO of Microsoft, or could be the director of Microsoft, or could be the CEO of, say, Ford. Okay, resource manager is your PM or president, whatever you would like to call it. And this is a country, this is a full country having four different states. So state one is having first chief minister, and second chief minister, third chief minister for each individual state. And whenever the client comes in, it creates the headquarter for the client called application master. From the headquarter, the various sub factories are created and gets done. Okay, so application master. Okay, application master basically is also running in the container, because application master as well as container is a foreign code. Okay, it's a foreign code. They should obey the law of the land. They should not do anything which is not right. Therefore, all of these are run inside container, and container makes sure that nothing leaks out. Okay, all right. Next question is from Parvez. Many questions were asked to the work types which are submitted to resource manager and ultimately to the containers. I would like to say here that clients have to submit the project plan to the resource manager, providing the details of, yes, that is a good analogy. Thank you. Okay, so the way, so whenever somebody is, s- clients have to submit the project plan to the resource manager, providing the details of the project they want to implement. Okay, question from Leela is, in the same state can be many AM and many containers? Yes, but no two application master, no two AM for same application. Okay, I'll describe to you here. All right. Now let me just go through the screens once more. I hope this is clear to everyone. Okay, this one should be clear to everyone. I want to look at this application lifespan again. So there could be some applications like MapReduce. Okay, what does MapReduce do? You submit a job, it does it per user, and then once it's done, it lets you know. Okay, so it's one application per user. If there is a new user coming for the same application, it'll create another application master. Okay, let's say I and you both want to do MapReduce. We submitted our job. It'll create two separate application master for MapReduce. One for you, one for me. Okay, so this is the definition of lifespan. So that too is flexible. That too is as per the requirement. Whether there has to be two application master for two different users, or one application master for all the users. Okay, then you could have another situation where one user keeps on interacting with the system for a very long time. So the application master keeps running for per user, okay, per session. If I have opened another console and started another process, then it creates another application master. Otherwise, it'll keep the same application master for me. So per user, but per session. Okay, one user could have many sessions. So that is another lifespan example. Third kind of lifespan is long running application. For example, HBase. HBase is a database, and what does database do? It keeps running all the time, listening to the queries and answering to your queries. So there could be a very long running or forever running process as part of yarn. So basically, that is the magic which is done by yarn, making it possible to probably cater to all kinds of workload, not only MapReduce, but all kinds of workload. That is the magic pulled by yarn. All right, so great. I hope I have answered your question, Leela. All right, and then you could as I told you, you could do this. All right, so you could do a cluster hands-on. All right, you could do a cluster hands-on. Okay, I would like to take the MapReduce in the next session. I've already gone through all of this. Okay, you should try changing the replication factor like this, and then try your own files, and then run the MapReduce example like this. Okay, for quickly, I'm running the MapReduce example here like this. Okay, so don't panic if you don't understand anything, because okay, so it says that it's not a valid jar. Don't worry. So we will just find it out. What's a valid jar then? I'll just put current. That's better way to keep. What? All right. Let me just find out. Let me just find out. Let me just find out the example. All right. So here we go. Can't we just put? Okay. So where is my command? Alright, so I'm trying to execute quickly this MapReduce command. Right now, just for give you a taste of it, I want to show you how does a MapReduce command looks to you. Alright, so here we go. So here we are saying Hadoop. Earlier we said Hadoop FS. Okay, where is that? We said Hadoop FS. This time we are saying Hadoop jar. Okay, so we are telling Yarn that hey, my logic is in this program, and we are trying to execute MapReduce. Okay, my logic is in this program, and my input folder is here, and output folder is this one. And since the output folder already exists, it gave us the error. So let's just say 6deb. All right, so you can see that it has started a background process which is running for us. This is called batch process, and you can see the URL. It says they cannot assign the requested address, probably. All right, so looks like now the request has been assigned. I don't know which machine is that. If it's not A, let's try B. B is not there. Let's try C. Okay, C is there. Okay, so it says that there are total number of one map, one reduce, and something is happening. And it has finished executing, and it has saved our output in mr out. Okay, I'll show you. Where is my home folder? All right, so all right, you can see mr out. This is what it just created, and this file represents the process has finished, and this is the output file. Had there been many phases, then there could have been more data. So we just computed the word count using the example internally provided. Okay, so all we did was we basically run this command. First we found where are the examples located. Okay, so you could also run it. I'm just copy pasting the command. Okay, just try it out. All right, great. All right, so we are almost through. The last question is from Anand. In the analogy where application manager master, this is app master, okay, is the headquarter? Yes. Do we have a copy of app master on another node? Generally, no. For it basically depends whether you are running per user, per session, how. In case where the node manager nodes where application currently fails, if if app master fails, then process fails. Okay, app master fails, then process fails. And I think the resource manager does not kick in automatically. I think the process would fail in case application master fails. All right, I don't think I think I was wrong when I was saying that application master creates. I don't think it resource manager creates a new application master. Okay, it generally gives an error, you can re-execute it, and that's it. All right, I need to check this part whether application master gets launched or not. Okay, brilliant set of questions, and stay tuned. So we on the next week we will go into more examples of MapReduce, and then we will move ahead. Okay, all right. Have a great day. Bye bye. So this code is available to everyone, Rajiv. Okay, the command which I have given to you just now, I have copy pasted. You could try out right away, and it'll work. Okay, because if you see the location of the files in here are absolute, which means they will work for you as well. You see, these are starting with slash, and this one data is also coming from slash data folder. Okay, it's same for you, same for me. All right, thank you, Sneha. I'm happy that. All right, Parvez. So Parvez, can I talk to you tomorrow sometime? You just give me a call tomorrow for some time. All right. Good night. Good night, everyone. Have a great day ahead. Bye bye. Thank you, everyone, and see you on the next Saturday. Till then, keep trying all the commands which we have tried, and just go through the slides and try to finish the assignments. All right. Bye bye.